looking at Eulerian and Hamiltonian walks. We're actually only going to look at Eulerian today. We're not going to worry about Hamiltonian at the moment. So basically, an Eulerian, we've got two options: Eulerian, Eulerian. His name's Leonhard Euler, so I'm going to call it Eulerian trails and Eulerian circuit. So an Eulerian trail is one that uses every edge of the graph exactly once, but starts and ends at different vertices. And then an Eulerian circuit is one that uses every edge of a network exactly once and starts and ends at the same vertex. All right, let's have a look. This first one. Now, Eulerian trails exist if the graph has exactly two vertices with an odd degree. It gets a bit confusing when you look at it like that. Let's have a look at it and see whether we can do it using exactly, every edge exactly once, and start and end at different vertices. All right, so if I started here, don't do that. If I started there, I could go bang, 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 and I could go to every edge exactly once, and I would start and stop at the same one. So this is an Eulerian circuit. Now, you could confirm that by saying every vertex has an even degree. Let's have a look at this. That one has a degree of 2, that one has a degree of 2, that one has a degree of 2, that one has a degree of 2. So yes. So every vertex has even degree. Okay. The next one, we're looking at it and going, okay, if I start here, can I go to each one and start and end at different vertices? If I go here, I can start, go up. Ooh, do I want to go that way? No, actually, I'm going to go this way. I'm going to go down, then up, then down. So I should probably put arrows on them. Then that way, then that way, then that way. So I started here and I ended there, but I still managed to cover all of them. Eulerian trail. I still managed to cover every edge only once. Now, what's the definition of this one? It says has exactly two vertices with an odd degree. So that vertice has 3. And do we have any others that have 3? 1 there. So we have 2 vertices with odd degree. Okay. Last one. Wherever I start, I'm going to go up, up, there, there, there. I can't get around that way, that way, that way, that way. No, that doesn't work. So this is actually neither. So I could try all of the different versions, but do I have exactly 2 vertices with an odd degree? That's got an odd degree, that's got an odd degree, that's got an odd degree. So I don't have that. And this one has to have every vertex with an even degree, and that's an odd degree, so that rules it out. So I can't fit into either of these little pieces, so I'm not going to have an Eulerian trail or circuit.